No, it's not due tomorrow. It's due sometime next week. So, but there is a homework quiz that's due, I think, tomorrow. Yeah, tomorrow by 5, I believe. Yeah. So don't forget that. Take a look on MathXL for that second homework, week 2's homework quiz. Okay. So let's wrap things up today with this short segment here on the last 2 trig functions we want to get under our belt is the secant and the cosecant functions. And you're going to like this. It's going to be very simple and straightforward. If you know your sine and cosine. So let's start, let's just stay in the same order. What I'm interested in working up is the secant of theta's graph. Now it is the reciprocal of cosine. It's the reciprocal of the cosine function. Reciprocal of the cosine function. So that's 1 over the cosine values. It's not an inverse. It's simply a reciprocal. So you take your cosine readings and you you take 1 and you divide them by your cosine readings. So in 10 seconds, I can tell you how to remember what the secant graph looks like. It simply rides on the cosine graph. It goes for a ride on the cosine graph. And now I can give you more details about that in a moment. But let me lightly dot in a cosine graph through more than one cycle. Okay? So here's a cosine graph through more than one cycle, through 2 cycles. From minus 2 pi to 2 pi. What I mean by riding on, look at this. Cosine, you get trouble in this fraction, don't you? If you divide by 0. So places where the cosine becomes 0, we have trouble. Again, similarly to what we just saw with tan and cotan, we're going to end up with vertical asymptotes at the zeros on that cosine function. So when theta equals pi over 2, we've got a vertical asymptote, and then also over here at 3 pi over 2. Notice how you always see me use dotted lines on them, and you always see me somewhere off the graph label the equation of that. Now what I mean by it rides on the cosine graph is it does the following. What's the reciprocal of 1? Still 1, isn't it? And if you start taking reciprocals of numbers less than 1, like a half, what's the reciprocal of a half? 2. What's the reciprocal of a third? 3. What's the reciprocal of 100? I'm sorry, the other way around. 100th. 100th reciprocal is 100. So what this graph does is it does this. This is what I mean by it rides on the cosine graph. Over here, we're taking reciprocals of negative numbers. The reciprocal of negative 1 stays negative 1, doesn't it? 1 over negative 1? Mm-hmm. And reciprocals of those others have to stay negative, don't they? Of these other negative numbers you see here. And so it takes a dive like this. There it is. Have we finished a cycle? Let's see. Let's go over here. What happens over here? Reciprocal of 1 is 1. These are positives. Reciprocals of positives stay positive. And these are numbers smaller than 1, like a half, a third, a tenth. Reciprocals of those become bigger than 1. And so the graph looks like this. Then what happens after 2 pi? Where does it go? Back up, doesn't it? Okay, so do you see that it looks like the behavior starts repeating itself right there? Okay. And so there's a period. There's a period. If I wanted to come back and draw some other regions of this thing, I could come back over here and lay these in as well. Okay? Notice that the cosine function you know is even. Look at the reciprocal. What do you think? The cosine function you know is even. Here it sits. Look at the reciprocal. Y-axis symmetry. Even. Happens to be even. We'll talk more about that later. So anyway, there's the cycle. The period is 2 pi on this thing. Same as the period of your cosine and sine. So in 30 seconds, we can end this. One last quick sketch. What about the cosecant graph? Rides on sine wave. Rides on sine. So you mentally think of a sines graph doing its thing, right? And simply lay it on there like this. Now I can give you a more sophisticated explanation of that later, but all you have to do is remember that, and that'll help you immensely as you move further along in math and science. Again, the period of this one is 2 pi, just like the other. Last quick comment, just in the interest of time. It'd be nice if we could spend all day playing with this, and then I'd really wear you out, okay? We have 6 trig functions, don't we? 4 of them, 4 of the 6 have periods of 2 pi. The other 2 have periods of pi, which are your tangent and its reciprocal cotangent. Can you remember that? Okay. 4 of the 6 periods of 2 pi. The other 2 tan and cotan periods of pi. Okay, see you in here tomorrow. That's it. No fourth segment today.